In the name of God. Hello, dear students. Welcome to Ferkhwa's website. We are here at your service to explain physics curriculum, grade 10. I'm Masood. I'm a physics teacher. And in previous lecture, I talked about the properties of matter, especially solids. And this chapter, you know that this chapter focuses on solid especially. That's why we talked about the 5 properties of, especially mechanical properties of solids. Right now, I'm gonna let's say move on to the 6th one, which is strain. Yeah, strain. So let's get started. What's the strain? Let me read the definition for it. It says the ratio between elongation and initial length. So it's the ratio between elongation, L minus L naught, and initial length means L naught, right? Mathematically, I can say E is, it's not E actually, it's epsilon. It's a Greek letter, it's not English letter, Greek letter. Epsilon means is equal to L minus L naught over L naught. This one is elongation divided by, this one is elongation, right? Divided by initial length. This is elongation, where L minus L naught together, right? Don't separate L and L naught. Together is called elongation. It's elongation measured in meter in SI actually. L naught is initial length and measured in meter. Epsilon, this called, you can write it like this, C, and it has a, let's say, small line, let's say, at the middle, or you can write it like this, epsilon. Epsilon is a strain and it's unitless. It doesn't have any unit. Why do we say it's unitless? Because whenever let's say, let me write the equation for you. Epsilon is equal to L minus L naught divided by L naught. L minus L naught is measured in meters, right? And L naught itself measured in meters. That's why M cancels M together. That's why they cancel together and nothing, let's say, remains. That's why we say it's unitless. It doesn't have any unit in SI, right? So we have a tip here. Let me read the tip for you and I'll explain for you. It says, under the same tension, the elongation of a longer wire is always greater than that of the shorter wire. You know this information. It's a Hooke's law actually. It's not a Hooke's law exactly. It's one of the causes, length. It's the factor of length actually. Length causes elongation. I told you in previous lectures, the longer the wire is, the longer the elongation is, right? The more the elongation is. And I mentioned this tip here again. It says, but the elongation. So the new information starts here, right? Till now, you know, it's the background for you till now. But after the comma, actually, this is new information. And I underlined it, I highlighted as a, let's say, yellow color. It says, but the elongation per unit length. What do I mean by elongation per unit length? It means L minus L naught divided by L naught. It means a strain. Elongation per unit length or strain remains constant for both wires, right? It remains constant. Elongation per unit length. What do I mean by this? Means for each, let's say, unit of length, for each meter, for example, 1 meter, let's say it has its own elongation. You have, for example, 2 meter wire. For each, let's say, unit of length, for each meter, let's say there's let's say elongation about the let's say this length especially, right? For example, you have a 2 meter let's say wire, and elongation of 2 meter wire, if you suspend the weight actually to the wire, what's the elongation of the whole wire? 2 meter long wire actually, maybe it's 4 centimeter. So you can say elongation for 1 meter is equal to 2 centimeter. What do I mean by this? Means elongation per unit length. Elongation per unit length remains as it is. Means a strain does not change. A strain for 10 meter wire, or let's say 2 meters wire, I don't know, 1 meter wire, elongation of course, elongation is different, right? But elongation per, let's say, per initial length, or I can say strain remains as it is, right? Strain does not change. So length of the wire, it's not significant for determining the strain. Strain is the same for, let's say, so I can say strain is independent of length of the wire, right? Whether the wire is short or long, no problem. It doesn't matter. Elongation remains as it is. This is about this note, actually. Recall that, remind that the two wires are made of the same material. You know this information. Wires should be identical in length and in material, and they should undergo the same tension, but here strain, or in other words, elongation per unit length remains unchanged, right? From the figure, we deduce that. We have a figure here. I drew a figure for you. I'm gonna focus on this figure and I'll explain it for you. And after that, I have a question for you. Let me bring it up for you and read the. So we have a figure, right? We have a, let's say, graph here. From the figure, we deduce that. So what's the figure? What does it talk about? It talks about two wires, yeah? These wires have the same thickness. They undergo the same, let's say, tension, but they have different length. This one, number 2, wire number 2 is longer than wire number 1, right? So here, this is the initial length for the wire 1, for example. Let me break down the information for you. For wire 1, we have L naught. L naught is equal to 1 meters. This is the initial length, right? Whenever you hang, let's say, mass, right, with the wire, what happens to the initial length? Of course, initial length elongates, right? The length increases from 1 to 1.2. So what's this part? This part is called elongation, or L minus L naught, which is 0.2 meters. So this part is equal to what? This part is equal to 0.2 meters. This distance is equal to 0.2 meters, which is called elongation, right? About the first wire. So about the second one, this is the initial length, which is 2 meters, right? Whenever you hang the same mass, actually, to the wire, what happens to the initial length? Initial length actually increases, but the elongation here is more than the elongation of this previous case because the wire is longer, right? So length is one of the factors that causes elongation, right? You have this information. This is background for us. I'm sure you remind this, let's say, information. It says, so 2.4, it's L, yeah? L. It's a final length. What was the initial length? L naught, 2 meters. I want you to find the, let's say, difference between the final length and initial length. When you find the difference between final length and initial length, means you found elongation, right? Subtract the initial length from the final length, and you have the number. This number, 2.4 minus 2, becomes 0.4 meters, right? I want you to compare between the elongation of either. What's the elongation of the wire number 1, which is shorter? 0.2 meters, right? What's the elongation of number 2, which is longer? It's 0.4 meters. So elongation for wire number 2, right? Elongation for wire number 2 is twice as much as the elongation number 1, right? So elongation differs, right? I want you to find the strength for each wire. Let me, let's say, do it for you. Epsilon is equal to L naught. L minus L naught divided by L naught. Let me write the equation. L minus L naught divided by L naught. Substitute the number here. L minus L naught, 0.2. Divided by what? Divided by initial length, which is 1 meter. So 0.2 divided by 1 means 0.2. And it's unitless, right? Let's find the elongation for the longer wire. right? A is equal to, let's say write it with another color. A is equal to, or epsilon, excuse me, epsilon. If you say epsilon, it's let's say better. Epsilon is equal to, and I'm not gonna write the rule again because you know the rule. L minus L naught divided by L, the same rule. But the number changes actually. L minus L naught means here 0.4 for the longer one. 0.4 divided by what? Divided by the initial length. What's the initial length? 2 meters. So 0.4 divided by 2 is equal to 0.2. You see? So 0.2 here and 0.2 here. What do you get actually? What do you conclude? We conclude that, let's say, however, the elongation for both wire differs, right? But elongation, let's say, for elongation per unit area, per unit length, elongation per unit length remains as it is. Simply speaking, we can say, instead of elongation per unit length, simply we can say strain for either becomes, let's say, constant, and elongation, and I can say strain does not change for, let's say, for both wire. Whether you have a shorter wire or you have longer wire, it doesn't matter. Elongation is equal to, let's say, it's the same, yeah? It doesn't change. So I solved it for you mathematically. Let me read the, let's say, notes for you. It says, from the figure below, we deduce that, we conclude that L minus L naught for wire number 1 is less than the L minus L naught for wire number, of course, you know, elongation for the shorter wire is less than the elongation for the longer wire. I explained it for you. Number 2, epsilon, let's say 1 is equal to epsilon 2. Strain of number 1 is equal to strain of number 2, right? So it's the same, which is equal to 0.2, right? 0.2, and it's unitless. It doesn't have any unit. So here, I prepared the table for you for, let's say, break the question down, right? I wanted to make it easy for you. Elongation, right, for the wire number 1 is equal to 0.2 meters. I found it for you mathematically. Elongation for wire number, right? Elongation for, elongation is equal 0.2 meters for wire number 2. We remain in wire number 1. Elongation is equal 0.2 meters. Strain 0.2 meters. So the first row, let's say, is dedicated for wire number 1. The second row, elongation for wire number 2 is 0.4 meters, right? I solved it for you. Strain for wire number 2 is equal to 0.2 meters. So I want you to compare the both wire together, right? Compare the information within the table. So where do you observe the difference exactly, right? So difference appears especially in this part. What do I mean by this? Means elongation differs. Elongation differs for each wire, but strain remains as it is. Or in other words, I can say elongation per unit length remains as it is. We have one question here. I prepared one question for you about this, about the strain. Why is a strain unitless? Why is a strain unitless? Because it's a ratio of two lengths. I told you. Because here, for example, L minus L naught is measured in meters, divided by L naught is measured in meters as well. That's why units, let's say, counteract one another. Units cancel one another. That's why. So nothing remains, and strain becomes unitless, right? So I'm gonna finish the lecture here. Thank you very much for watching this video, and I want you to follow our videos, our next videos, and bye for now.